Hey everyone, and today we have another LeetCode problem, problem number 665, non-decreasing array. And while this problem isn't super challenging, I think I like this problem because it's pretty tricky and I think people assume that the solution is easier than it is. And so let's read the problem. Given an array nums with n integers, your task is to check if it can become non-decreasing by modifying at most one element. We define an array as non-decreasing if nums I is less than or equal to nums I plus 1 holds for every I 0 base such that I is greater than or equal to 0 is greater than or equal to n minus 2. And in other words, this means that for an array to be non-decreasing, it either needs to be increasing or the two elements next to each other have to be equal. So for an array like this, we have 2 is less than 4, which means this array is non-decreasing, or it is decreasing, but we are allowed to modify one element. So if we modify this 4 to a 1, then we get an array 1, 2, 3, which would be a non-decreasing array. And here, this is also a decreasing array, but we can't modify one element because every element is smaller than the one before. And so at first, I think the solution that I came up with and most people come up with was they just say, okay, well, if I have an array like 4, 2, 3, what if I just find the point where it's decreasing and I just modify my number to make it non-decreasing, and let's see if that just works. So I just find the one place I can make a change, and if I find another place that I have to make a change, then that's fine. But there are some problems with this, and that's why this is tricky as well. You can't just find one place where there's a decrease, and if there's another place, you return true. So, or you return false. So if you get something like this, you can't just be like, okay, well here it's decreasing and here it's decreasing, and I can only modify one. So because there are two locations where it's decreasing, I can just count up the number of locations where it's decreasing, and if it's more than one, then I know it's false. And let's try to find an example where that doesn't hold true. And also you could tell that this kind of solution wouldn't work, where you just count the number of places it's decreasing, and if it's more than one, you return false. Because there's a kind of a hint, the acceptance rate for this problem is really low. And so this kind of tells you that the examples that are given make it seem like there's a really obvious solution, but that's not working. So let's try to come up with a solution that doesn't work for this kind of case where we just count up how many places the array is decreasing. So what if we had a solution like this? Or actually even better, let's get rid of this one here. So if we had a solution 5, 4, 2, 3, well, in this solution, it is decreasing twice. Actually, so instead of this 5, let's do this actually. 3, 4, 2, 3. So this solution is increasing here, decreasing here, increasing here. So there is only one decreasing location. So if you had the algorithm of where you just look where it's decreasing and count up the number of times, this would say it's 1, so this would be correct. And this would return true. But however, if you try to change this value, so it's decreasing here, can we change these values in some way to make it non-decreasing? Well, let's try that. So this 4 can only be changed to a 3 at the smallest. And so if this 4 becomes a 3, because this 4 has to be greater than or equal to this value, so if this becomes a 3, then this is still decreasing. So we can't do that. Okay, well, can we change this 2 to make it non-decreasing? So this 2 can be changed to a 4, but it's still going to be decreasing, so we can make it a 4, because then this part wouldn't be decreasing, but this part is. So you can see that this example breaks the solution where you just count up the number of decreasing sections and you just return true. So we have to do something else. So let's think of how we would solve this problem, where we have this 3. Okay.
So what are the options we can have? Sorry. So this problem, actually, there's no way to do anything. But let's think how we would solve the general case of this problem, where we just had some numbers. Well, anytime we reach a point, so let's just say we have some ambiguous numbers like 4, 2, 5, 3, 1, let's say. Or actually, we can go back and use our previous example. So let's just do that. So 3, 4, 2, 3. So let's go back and use our previous example about how we would check that this is not a valid non-decreasing array. Well, once we hit one point where there is a decrease, which is here, we want to try to have some kind of a variable that tells us, hey, we hit a point that this is decreasing, so we can have some kind of Boolean value here. And we can just say, yeah, we hit a point where it's decreasing, so we are going to use our one given modification. And if we are given our one modification, what would we want to modify our numbers to? And there's a couple of cases where this might be different. So for example, let's say we have something like this. And these are our two numbers. So if we start at the start of an array, what can we do? Well, this first number can be changed to anything because there's nothing in front of it. So we don't have to, like if it's in the middle, this would have to become 3 or less. Well, it's in the front, this can be anything. And our goal is to minimize this second number, so that way when we check further on, we hopefully don't have a decreasing array. So our highest chances of not having a decreasing array is of minimizing the second number. So how would we minimize the second number in this case? Well, we would just change this first number to the second number. So this 4 can become a 2. And now this is the smallest number this can be. So that's if the two numbers at the front of the array. Well, what if they're in the middle of the array? What can we do? Well, and let's think of some cases you can have in the middle of the array. So let's think for this case. You have this. And can we just change this number to be equal to this number? Well, no, because there's a 3 here. So the smallest number can be is a 3. So if the smallest this number can be is a 3, that means we can't make this number smaller than this number, which means we have to change this number. And so what would we want to change this number to? We use our one change. Well, the smallest number we can make this number now is this number here. So what we would do is we would take this 2 and we would change it to a 4. And then we would keep going, and if we ever hit another decreasing segment, then we know that this doesn't work. So we change this to a 4, then we hit another decreasing segment, and we checked, did we already make our one change? Yes, we did. So then we have to return false. Now there is another case where we have something like this. So we have this segment again. It's not at the start. Now what would we do here? Well, we can either modify this number or this number. The smallest this number can be is a 1, but it doesn't really matter in this case. We can either make it a 1 or a 2, but the easiest thing to do would just be make this number on the left equal to the number on the right. And how are we able to know that that's the case? Because the number to the left of this number, so this number, is less than or equal to this number over here. So let's write our steps here. Step 1, find a decreasing segment. Step 2, if the segment is at the start of the array, modify the left value. Close this. Modify the left value to be equal to the right value. This would minimize our right value. And also, if the segment is in the middle of the array and the number to the left of the left value is less than or equal to the number to the right. So this number to the left of the left value is less than or equal to this number to the right. That means we can modify this number to the left to just be the number to the right, and that would minimize this value here. And then our last case is if we can't modify the left value, modify the right value to be the left value, because that would minimize the value here. If we can't change this number, the smallest this number could possibly be is 4 for it to be non-decreasing. And then we keep traversing, or we update the bool value and keep traversing. And if we hit another decreasing segment, we used up our change, so we can return false. So we're going to keep going down the array, and once we modify one value, we're just going to say, okay, we used our modification, and if we hit another decreasing segment, then we know that this array will be a non-decreasing array. So then we can return false in the loop, and then at the end of the loop, once we traverse the whole thing, if we haven't returned false, then we know it's true. Okay, so let's try to code that up. So we're going to need some kind of a Boolean value to see if we used our change. So we can call that change used. We're going to start with false. We're going to iterate through every value in nums. And we're actually going to not iterate through the last value, because when we're at a value, we're going to compare the value that we're at to the value to the right. So we don't need to use this last value because there's nothing to the right. Once we get to this last value, then we know we're good. So if nums I is less than or equal to nums, this should be I plus 1, that means that this is fine. So what we can do here is we can simply just go to the next iteration of the loop. So we can just have it continue here. And then if we didn't go to the next iteration of the loop, then this changed used value is going to be true, because we are going to need to change. We hit a decreasing segment, so we are going to need to change that value. So we can just say change used equals, or actually, sorry. So we need to do one more thing. So if we did hit a decreasing segment, we need to check, did we already use our change? So if we did, then this is where we return false, because we already used our change and it started false. And then now we can make it here equals true. And now we need to check, remember, is our value at the start, or is the segment to the left of it less than or equal to the segment to the right of that? So let's do that. So if I equals 0, which means our value is at the start, or nums I minus 1 is less than or equal to nums I plus 1, then we are going to change the value to the left to make it equal to the value to the right, and that would minimize the right value. So let's do that. So I equals nums I plus 1. Otherwise, we can't change the value to the left, so we have to change the value to the right, and the smallest value that can be is the value to the left. So, okay. And then we just simply can return true when we traverse the entire loop, and that should be the code. So let's try that. Okay. So if nums I is equal to valid syntax. No, actually no, that's fine. It's probably because I had that space. Okay. Okay. So now let's think about the time and space complexity for this one. So time So what are we doing? We are iterating through this entire array, and when we do modify, when we do get to a segment, we just change a couple values, but we're not creating any other data structures. We're not really going into some inner loop. So our time complexity will be worst case. We have to go through the entire loop, because if it is a non-decreasing array, we're going to get to the end. So our time complexity is O of n, where n is the length of this nums array. And our space is pretty straightforward. We're not making any other data structures, so it's just O1. We're just using temp variables. Okay, so that's all for this one, and I'll see you in the next one.